There is a simplified way of doing dividing of polynomials using something called synthetic division. The problem with synthetic division is that the divisor, what you're dividing by, must be in the form x minus a. That means it must be linear. So if you're dividing by something like x squared plus 2, that's not linear. This process will not work for that particular polynomial. But most of the polynomials we're going to deal with are going to be linear. So let's do an example of what synthetic division is and how it works. In problem 3, we want to divide x cubed minus 14x squared plus 51x minus 54 by x plus 2. Just like with regular polynomial division, make sure that there are no missing terms in your polynomial. Make sure it's written in descending order of powers. If you look at this particular polynomial, you'll notice that the biggest exponent is 3, and all the rest of the exponents go down by 1 each time, so all the terms are there. So what we do is we start by taking the divisor and you set it equal to 0 and solve for x. Oops. That number that you get when you solve goes in a little, like a half a box. Next to the half of the box go only the coefficients from the polynomial you're dividing into. The coefficients are the numbers in front of the variables. So the coefficients are 1, negative 14, 51, and negative 54. And notice that I gave myself some space between each coefficient. It is not uncommon for students to try to write the numbers close together, and then they would mistake the middle term for maybe being 145 or 1451. So make sure you give yourself space between each coefficient. And then you draw a line underneath. Notice again that I gave myself some space. So you bring down the first coefficient. Then you're going to write a number here. The number you're going to write there you get by multiplying the number in the box by the number under the line. Negative 2 times 1 is negative 2. And then, to get the next number under the line, you're going to add this way. We always add down. Negative 14 plus negative 2 is negative 16. To get this number, we're going to multiply the number in the box by the number under the line. Negative 2 times negative 16 is positive 32. To get this number, we add going down. We get 83. Then to get this number, we're going to multiply the number in the box by the number under the line. Negative 2 times 83 is negative 166. And then we add going down. And we get negative 220. The last number is always the remainder. The numbers before it are the coefficients of the quotient. And the quotient is always 1 power less than the original polynomial. The original polynomial started with x cubed. Therefore, my new polynomial is going to be 1x squared minus 16x plus 83, with a remainder of negative 220. On your own, I'd like you to divide x cubed minus 57x plus 56 by x minus 7. Hint: there is a missing term in this polynomial. Now you're ready to set up synthetic division. Problem 4 refers us to something called a shadow box on page 323, but I've drawn a picture of kind of what the box looks like. The polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the shadow box shown on page 323. They do give you a piece of information. They tell you that one side of the box is x plus 5. What are the dimensions of the box? All right, so the dimensions, because we're talking about volume, are length, width, and height. And I actually know one of the 3 sides. So in order to find the other two sides, I'm going to use synthetic division in order to find what I get when I divide out the one side. In order to use synthetic division, I'm going to set that factor equal to 0 and solve for x. -5 goes in a little box, and next to the little box are the coefficients of the original polynomial. Remember to check the polynomial to see if there are many missing terms. There are not. 1, 7, -38, -240. I draw a little line down here. The first number always goes below the line. The next number above the line you get by multiplying -5 times 1. And then you add going down. The next number above the line you get by multiplying the number in the box by the number under the line. -5 times 2 is -10. The next number above the line I'm going to get by multiplying -5 times -48. And then I add going down. The last number is always the remainder. The other numbers are the coefficients of the quotient. So the quotient is always 1 power less than the original problem. The original problem was x cubed, so the new problem is 1x squared plus 2x minus 48. Well, I know one of the dimensions. They told me one of the dimensions was x plus 5. To find the other two dimensions, I'm going to factor this trinomial. I'm going to look for the two numbers that when you multiply them give you -48, but when you add them give you +2. Well, those two numbers are going to be +8 and -6. So this is my length, width, and height. My length of this particular box in the picture, they told me in the problem, although I didn't write it here, the length is greater than the height or depth. So this must be the length. This is the width, which I got from the picture, and this is the height. In part B, if the width of the box is 15 inches, what are the other two dimensions? Okay, so we had just said a minute ago the width was x plus 5, the length was x plus 8, and the depth was x minus 6, so that's the height. So if the width is 15, x plus 5 is equal to 15, so x must be 10. Well, if x is 10, and we know this is 15, then the length must be 18, and the height must be 4, and they are all in inches. On your own, I would like you to find if the polynomial x cubed plus 6x squared plus 11x plus 6 expresses the volume in cubic inches of a box, and the width is x plus 1 inches, what are the dimensions of the box? And I give you a picture of a box here if it makes you feel better, and some of you like boxes that look like this, and that's fine as well. When we have a remainder at the end of a polynomial, it turns out that there's another way to find that remainder if that's really all I care about. The remainder theorem says if you divide a polynomial p of x of degree n greater than or equal to 1 by x minus a, then the remainder is just p of a. So, in other words, it says given that p of x is equal to x to the 5th minus 8x cubed minus x squared plus 2, what is p of 3? This is the same thing as asking, what is the remainder when you divide by x minus 3? Now, we don't have to do synthetic division to find the remainder, but you can. What you can do is you can literally just plug 3 in place of x, and then shove that in your calculator and hit enter. And that's how I'm going to start this problem. But I am going to show you that synthetic division also works. So instead, if I put 3 in my little box, and then I put the coefficients of the polynomial next to it. Remember, there could be missing terms. There's x to the 5th, but there's no x to the 4th. There's an x cubed, x squared, no x, and a constant. In order to do the synthetic division, the first term comes down, and then I multiply by the number in the box to get the next number. I add down, multiply by the number in the box, add down, multiply by the number in the box, add down, multiply by the number in the box, add down, multiply by the number in the box. Oh, I did something wrong. That shouldn't say 18, that should say 6. Sorry. Multiply by the number in the box, and then add down. And the last number is always the remainder. The remainder theorem says instead of doing synthetic division, if you take the number you would normally put in the box and just plug it into the original equation, you will also find the remainder. Just remember, we're not always just looking for the remainder. Sometimes we want to know the quotient. On your own, I'd like you to do this problem. Given that p of x is equal to x to the fifth minus 3x to the fourth minus 28x cubed plus 5x plus 20, that really does say 20, what is p of negative 4?